Right, let's have a look at TOFD. Click on this TOFD button here. Now the TOFD system uses a transmitter and a receiver this side, rather like through transmission. Now the major difference is that these angle probes are actually transmitting compression wave, which we normally associate with a zero probe. So this is transmitting compression wave at 6,000 approximately meters per second in steel. And here is the receiver this side. We normally set the distance apart so that the center of the beam meets at 2/3 depth. This gives the best response for all weld coverage. You can see the center of the beam is crossing the 2/3 depth line there. We've got our range control. And our amplitude. Now the first thing to do is find the initial pulse, find the lateral wave. There it is there. Squash the range up so we can see the back wall. Now the concept of TOFD, time of fraction, the concept of TOFD is time of flight diffraction. That's what it stands for. The sound is transmitted and received here. But the edge of the beam actually runs just underneath the surface, shown by this yellow line here. As that is received, the first pulse is shown on the A scan. Notice that it's an unrectified A scan. The initial pulse here is actually called the lateral wave, and it's always quite a small signal. We can increase the amplitude, something like that. Now as the sound hits the back wall, it is transmitted up again and received by the receiver. A much larger echo here. And the method of displaying it is in a black and white grayscale strip chart. Click Start. This is represents the lateral wave here. And this represents the back wall. I'll change the brightness. So this is the lateral wave shown here. This is the back wall shown here. Other indications in here are in fact defects. Stop the scan. Defects. Let's make up some defects. Delete all defects. I'm going to put in a small defect here like that in the first one, a root defect here in the second one, a surface defect here in the third one, and a large defect here in the fourth one. Run the scan. We can see the A scan, some defect signals here, another defect signal. Now, let's stop at what we've got here. We've got the lateral wave representing the surface. Notice the surface's lateral wave is being broken here. Let's click here and see. The lateral wave hit this defect on the surface, so we've lost our lateral wave. The lateral wave has gone here as well. In this one here, we can see the top and bottom of the defect. Now the concept of TOFD is it will only show the top and bottom of a defect if we're lucky. So we cannot see the bit between the top and the bottom. So here we can see the top and the bottom of this defect. The distance between them represents the height. On this one here, we can see that we've got a top and a bottom here on the display, representing the top here and the bottom here. And for the root indication, we can see here a loss of back wall, and there is the top of the root defect. Let's scan the whole thing. And I'll stop it there.